This video is on the slope of a linear function. And to start off, I'm just going to kind of point out that there are 4 types of slope that you may see in your class. The first one would be a positive sloped line. The next one would be a negative sloped line. And then you might see a slope of 0. And then you might see something that has an undefined slope, and it's not a function, but we call the slope undefined. So let me give you an example of each of those graphs, if I could. So here is your coordinate plane. Just real quickly draw a sketch of these, right? So you've got your coordinate planes, and then linear functions are lines, right? Straight lines. And there are 4 potential types of slope that you could have. Alright, so here we go. The first one would look like this. A positive slope line would do that. A negative slope line would be going down from left to right. Slope of 0 means there's no change whatsoever, so it just means it's flat. It's not increasing, it's not decreasing, it's just flat. So there's no rate of change, so the slope is 0. And then undefined would be something that is not a function, so it's a vertical line. So a vertical line creates an undefined slope. So there are your 4 types of slope, right? So once again, the first one is going up from left to right. It's increasing. The rate of change is going in a positive direction. Negative, the slope is negative when the rate of change is negative, and then 0 is 0 when there's no increase whatsoever. Alright, so let's just find 2 examples where we actually have to find slope, and I think it's best to see it visually. So the first graphic that we have here is just a graph. It's got a negative slope, we can tell because it's going down from left to right, and you've been given 2 points. So anytime that you've been given 2 points, there's 2 things that you could do in regards to finding slope, and I will talk to you about each way. So finding slope between 2 points. The first way is you can use the slope formula. So the slope formula is as follows. M, which we use for the slope to represent the slope, is y2 minus y1 divided by x2 minus x1. And so we call these x and y, right? Our coordinate points. Let me use a darker color so you can see that. We call those x and y. And so the first point is y1 or x1 and y1, and the second point is x2 and y2. And it doesn't really matter which one you call what, but I'll just label those as x2 and y2. And then you can follow the formula that I've set up for you here. So in my formula, I've got m equals y2 I've got as 12 minus y1, which I've got as 16, divided by x2, which is 15 in mine, minus x1, which is 5. And then we're just going to follow the formula. So the slope equals negative 4 over 10. 15 minus 5 is 10. And then you would reduce that. So the slope is negative 2/5. And so that is our slope of that line. Now another way you can do this, and some people when given a graph enjoy this way better, is what they're going to do is they're going to start at the point to the left, and they're going to do what we call rise over run. And they're going to count down, and they're going to count over. And so how many spaces or units have you gone down? Well, to go from 16 to 12, that would be 4 units down, so that's negative 4. And then how many units have you gone to the right? Well, you were at 5, and now you're at 15, and so that'd be 10 units. And so then you would do rise over run, so negative 4 over 10. Negative 4 is the rise part, even though it went down. And then over 10, which is the run part, still getting you a slope of negative 2/5. So either way, you can get negative 2/5. Some people like looking at the graph. Some people like using the formula. It's just up to you. So let's try one more. All right. We know that the slope formula is m equals y2 minus y1 over x2 minus x1. And so I'm going to call this point x1 and y1, call this x2 and y2. And so we would have m equals 5 minus 20 divided by 5 minus 2. And so we're going to do 5 minus 20, which is negative 15, and 5 minus 2, which is 3. And so what's negative 15 divided by 3? Hopefully you came away with negative 5. And if you wanted to look at that from a graphical standpoint, you once again would count down. So how far from the left point? You got to always go from the point that's on the farthest to the left. So how far did you go down? You went down 5, 10, 15. So that'd be negative 15. And then how far did you go over? You went over 1, 2, 3. And so the negative 15 over 3, which is negative 5. And you may be thinking, can the moving right or left, or the moving to the right, could that be negative? And my answer to you is no. If you start it to the left point always, then the up or down will be related to positive or negative, and then the movement to the right will always be positive. And those are a couple ways that you can find the slope of a linear function. All right, have a great day.